Hello, my name is Pablo Alvarado. I'm co-founder and CEO of Minero Inc. Today I'm going to talk about Minero Suite 1.0, latest Minero enhancements in Plan Optimizer and Smart Pit Designer. Let's double click in the Minero icon to start and let's open a project. Everything changed, metal prices, operating costs, metal recovery, etc. Some variables change all the time, other variables change from time to time. My planning engineers need to have world-class tools can allow to make best decisions to optimize and design their pits. Then my planning software can create multiple pit shells and open pit design applications can handle complex geotechnical constraints are mandatory. Minero in the module plan optimizer can create multiple economic pit shells. Minero in the module smart pit designer can create pit dam designs in convenient time. In this exercise, I will be using applications of these models. To create multiple pit shells, I will be able to work with complex geotechnical constraints as well. Minero's goal is to support professionals from the mine planning and strategic planning to make the best decisions with the purpose to create their optimal pit shells and open pit designs. I use online available McLaughlin block model in this exercise. Here is basic information of the model and the economic parameters. McLaughlin non-operational gold mine located in California, USA. Block model more than 2 million blocks. Size 25 by 25 by 20 foot. Economical parameters as shown there. Gold price, mining costs, process costs, and recovery. I will use these economic parameters in Minero compute value application. And I will be running three scenarios, starting with gold price $1,200 per ounce, then $1,250 per ounce, and $1,300 per ounce. The other parameters will continue the same. Also, I created 5 different geotechnical domains. Domain 1 is in the middle, slope angle 45. Domain 2 is in the north side. Domain 2 actually is in the east side, 53 degrees. Domain 3 is in the north side, 56.31 degrees. And domain 4 is 60 degrees, is in the west side. And domain 5 is in the south, 63.43 degrees. These 5 geotechnical domains can be added in optimal pit and slope projection application, user interface in no time. They can create multiple pit shells and designs. Like we saw in compute value application, we will define economic parameters and these results can be used in optimal pit application. Also, geotechnical constraints can be defined in optimal pit reset option UI. I'm going to go to optimal pit. I'll load compute value configurations, value 1, compute value 2, and compute value 3. So the row sets UI is underneath, and we can use the domains variable, and here is where we can define our row sets domain by domain. Domain 1, 45 degrees, domain 2, 53, and so and so. So then when we run this optimal pit, we will get results. The pit shells generated at 1200, pit shells generated at 1250, and pit shells generated at 1300. These three results give us an idea how the pit shells are sensible to gold prices. In purple, $1,200 per ounce. In green, $1,250 per ounce gold price. In white, $1,300 per ounce gold price. Other sensitivity analysis of other parameters such as cost can be achieved as well. But we are fine in this exercise with this gold prices analysis. In the second part of this exercise, we can create open pit designs. This time, the application that I will be using are slope projection, road information, slope projection, road settings, toe and crest, offset settings, and trim and cut tools. As a reference, I can use one. I can create OpenPit design using one of them. I'll be using the $1,250 bronze pit shell. So let's say this is the north side of the pit, and this is the south side of the pit. Here's how it looks like the north side. It was created using OpenPit design criteria. And the beauty of this design is that the bench by bench user can decide what to include in the OpenPit design. So this domain, this pit design up north pit, and domain is inside, mostly is inside domain 3, 56.31. We have also the other design, south open pit. South open pit is inside domain 1, 45 degrees. Part of it is inside domain 2, 53 degrees. And there's not a small part is inside domain 3, which is 56.31 degrees. We can notice here the 45 degrees for a bench of 20 our circle, the major circle radius is 20, so the distance between mid-bench to mid-bench is 20. While here in this area of 53 of domain number 3, 56.31 degrees, the distance is 13.3 from mid-bench to mid-bench um, between these lines. That's the distance. Okay. Let's see how it looks like the design in 3D. Let's see the ultimate bit as well. And the ultimate bit is this one. And off some of the objects. Once again, we accomplished another activity in Minero. This time we were able to create optimal pit shells, open pit designs. Don't hesitate and visit us at our webpage www.mineromining.com. We'll be happy to answer your questions and suggestions. In the name of the Minero team, I must thank you for your time.